Good afternoon. Walking through the very busy crowd out there, I saw a lot of carbohydrate and not so much coffee. So I'm hoping I can keep you awake and there's no food comas going on. So I'm going to be covering Windows and .NET on AWS. I am an architect, and actually, I think this pretty much marks the 3rd year anniversary of my career at Amazon. And I actually joined Amazon Web Services in Singapore. So literally 3 years ago, I think I arrived on an airplane and became a member of Singapore. I'm back in the UK now, so it's a huge privilege to be back here visiting and up on stage in front of you. So thank you very much. I've got a ambitiously broad agenda this afternoon for you. So I'd like to actually see a quick show of hands, if I can, for those in the audience who are already using AWS. Actually, quite a lot of people, that's good. And how many of those people are actually running Windows workloads on AWS? Okay, quite a good number. And out of those, who really represents the sort of infrastructure and operations view first? And how many people sort of representing more of the sort of developer community? There's something missing. If I add those numbers together, they don't quite work out. So there's something I've missed there. Is it operations? There's something else I just missed there. But anyway, so there aren't any questions in this session. It's being live streamed. But please, I will be around afterwards outside in the other area. So please approach me and ask any questions that might be gnawing and eating at you during the session. So first up, what are the benefits of running Windows on AWS? Right. So this will answer the can I, should I question. Then we're going to look at the what are the foundations, and primarily there I will focus on networking and security. Will you run your Windows infrastructures in an isolated cloud-only model, or are you going to integrate them and extend your existing infrastructure? Then we're going to move on to the sort of packaged applications. So that's the sort of the SharePoints, the Exchange servers, the Link servers, the Microsoft Dynamics platforms. How do they fit into the picture? Because I think any sort of big Microsoft estate out there is going to have all of those components. It's not just Windows Server. And then after that, we're going to have a quick look at the database options. Primarily, that's going to be SQL Server. Obviously, we could talk about all sorts of database platforms, but we're going to focus on SQL Server. Even though things like MongoDB are also very popular with the sort of the .NET and Windows crowd. And then finally, we're going to get to probably what's my favorite part, because I'm ex-Microsoft certified solutions developer, although that's probably lapsed in the last few years. So then we're going to move into the custom application development space. So first of all, first thing to say is that Amazon Web Services is absolutely optimized for the Microsoft platform, and it's very, very popular. And why does that matter? If it's popular, it means there's a big ecosystem out there. It means that if you were to go onto Stack Overflow or Stack Exchange or the AWS forums, you're going to find lots of other people working through and deploying applications, asking questions, getting great answers. So you're part of a big ecosystem, and that's very, very useful. It helps propel you forward very quickly. You won't find yourself hitting problems that haven't been solved already or already been distilled into best practices. But of course, there are some very specific optimizations, such as Visual Studio toolkits, .NET SDKs, PowerShell command lines, vCenter plugins, System Center plugins. There's a lot of specialized components built to make that experience a lot more pleasant. So then we're going to look at security. We recognize that security is probably the #1 barrier to entry to the cloud. It's why people are most hesitant. They want to know they're going to be secure in the cloud. And actually at Amazon, that's our #1 priority. Often internally, we refer to this as job zero. Ultimately, if we don't get security right, we don't have a business. That's web services, that's Amazon.com. It is job zero. It's most important to us as well. And so we want to sort of make sure that you understand how that we go through the layered security model. We have what we refer to security of the cloud. So So what do we do in terms of the physical security, the operational security, the way we build our software and deploy it, as well as security in the cloud. So what tools and processes do we give you as customers to secure your applications and data in the cloud, right? There's a shared responsibility there. And then what we're going to look at is sort of identity and access management. What do we provide, especially in the Microsoft world, is ADFS support. So you get that single sign-on experience and federated security. So you can log in, go to a portal, and all your users and groups and domain membership is conveyed into the AWS environment. So you get fine-grained control of who can do what inside your AWS infrastructure. So you're probably now thinking there's two parts to this equation, right? There's the infrastructure, there's the who can do what in my infrastructure, so who can create servers, who can terminate servers, and then there's the Windows security on top, so who can actually log into those Windows servers and do things inside those Windows environments, and Active Directory and so forth. And whilst in Windows you've got things like event logging, performance monitor, you've got ways of monitoring and tracking and auditing your infrastructure. What sits underneath it is the AWS infrastructure. How do you get auditing and logging of that infrastructure? So we have tools and technologies like CloudTrail and AWS Config, which are tools that help you essentially, so CloudTrail is essentially going to log all of the API interactions. Yeah, so everything that you do, whether it be through a command line, through a SDK, whether it be through Visual Studio, the GUI console, everything ends up being translated into an API call, okay? And that means that CloudTrail can log those actions, and it can also log not only the requests that you make, and also the responses. So now you have a very detailed audit log of who did what with your infrastructure, when they did it, what keys did they use. So that can really help with troubleshooting, audit and compliance, and forensics, and those logs are securely stored away. AWS Config is a resource inventory. So what infrastructure is exactly running right now? I mean, every single component. We're not just talking about your Windows servers. We're talking about your networking configuration. We're talking about all the elements, your firewalls, everything that goes into making up your infrastructure. Everything is software defined, so therefore everything can be described accurately at any moment in time. And that's quite a leap forward over traditional infrastructure. And it's important to note that AWS has 18 independently validated security certifications, and that means it's quite possible for you to deploy and manage an infrastructure that's essentially operating at the superset of all of those accreditations. You probably won't, but you could do. Infrastructure has to be reliable, and by that, we want to make sure that the expense of downtime is avoided. Right? The expense of downtime is not because a few servers were off for a few minutes. It's the impact of the ongoing business. And there's two parts of that. There's one, which is us making sure that we meet our SLA of 99.95%, but it's also for AWS and our best practices and our white papers to help you build and architect on that platform to actually achieve much higher than that. We have 28 availability zones around the world clustered into what we call regions. So you can deploy your applications and infrastructure around the world. Each one of those availability zones itself is made up of 1 or 6 data centers, or 1 to 6 data centers. Each one of those data centers may have anywhere between 50 and 80,000 servers. So you've got a very large, globally deployed infrastructure so that you can withstand significant natural disasters or just very rare system failures. We also give you a lot of visibility into that infrastructure. So there's the Service Health Dashboard, which is a status dashboard, a web page that you can visit to actually explore the current status of any one of those services in any one of those regions. That's also available as an RSS feed, so you can consume that programmatically and also look back in time at the service track record. I think it's really important for customers to be able to see that, to be able to build their confidence and trust in deploying those applications onto this platform. It's also important to note that on some of our infrastructure, you can actually deploy what's called SRIOV and enhanced networking. So for very high-performance compute workloads, whether it be HPC or big data workloads, you can actually get very, very high packets per second transmission between those servers with very low network variability. And that's really important for the sort of high-end HPC workloads. This is absolutely not just for dev and test environments. Okay. High performance. Now, I could talk to you about all the different virtual machine types and all the different storage types and whether you can get high performance ones or less performance ones and strike the right balance. But I also think high performance is as much about high performance teams and high performance companies. So that means not only do you have immediate access to enterprise grade IT, so, whether you want one server or 1,000 servers in minutes versus weeks or months. It's also about making sure that you have the ability to remove what we call undifferentiated heavy lifting. So high-performance companies, high-performance teams do not spend their time on repetitive, error-prone, time-consuming tasks, which is why we give you tools like CloudFormation to automate these things so that you can actually control and manage whole collections of resources. And I'll show a little bit later how through things like CloudFormation, you can actually deploy and punch out SharePoint environments, entire environments with Active Directory, failover clustering, web front ends, the entire environment, all the networking and security that goes with it, and just click a button and deploy it in a matter of, it probably takes a matter of an hour or so to actually fully deploy all of that infrastructure. But it's repeatable, it's predictable, and it removes the need to waste time as a team. It removes that undifferentiated heavy lifting. Of course, high performance also means auto-scaling, very important feature of AWS, the ability to, on demand or manually or on a scheduled basis, scale out your infrastructure and, of course, scale it back in again when the demand has gone away. But importantly, in the Windows environment, I find it quite helpful to remind people they can also scale up. Okay, so you may find, if you're looking at your resources, that over time you're finding that the workload is becoming more demanding, CPU utilization is going up, memory is under pressure, especially with the database, and you may actually, at the push of a button, want to restart that machine and make it come back to life as a much bigger machine. Of course, it goes the other way, so if a project or an initiative is maybe not going as well as you'd like, then you can start to scale that back as well. Really important, familiarity. We recognize that a lot of you who are working with Windows have been working with Windows for a very long period of time. You don't have time to go through a retooling process and go on a big, big training program. What you really need is to get working really quickly. And so therefore, it's really important that you have a very familiar experience. And in many ways, I could have really shortened this whole presentation and just said, because I get asked this question, which is, so how do I do that on AWS? And my usual answer is, well, what do you do today? Okay, so do you use System Center? Do you use Active Directory? Do you use Visual Studio? All the standard tools that you would use to automate and manage a Windows infrastructure, that remains true also on AWS. We do have some additions. We give you the ability to have what we call dedicated server instances. So if you've got like a direct connect or a VPN that's connecting you to your on-premise infrastructure to the AWS cloud, you've got dedicated instances. That means that your workloads are exclusive on those host machines, okay? That means, yes, it's multi-tenant in that you may actually have multiple virtual machines running on that machine, but you are the only customer running on that. And that actually can be very useful because it gives you much more flexible licensing terms. So if you look at the agreements around license mobility through software assurance, dedicated instances are an important vehicle for helping you bring your licenses that you've already bought and bring them onto the AWS platform. It's important to say cost-effective. One of the most important things is we're finding customers, such as Slalom mentioned up here, is that they're actually telling us that they've moved to AWS, they're getting higher performance, they're getting higher throughput, but actually they're doing that at a lower price. A lot of that will be down to auto-scaling or what we call right-sizing. So actually, as their workloads are deployed, they can look at real metrics, real data, and change the infrastructure to match the workload, rather than just the traditional process of planning, predicting, investing, buying, procuring, racking, and then finding out that it's either too small or too big, and if it's too big, you can't hand it back, so well, it's just going to run underutilized, and you've got maybe a task of trying to put other workloads onto this hardware. So what we have this process of helping customers right-size. And of course, you can bring your own licenses. You can buy Windows and SQL Server licensing through AWS as a service provider. And that's a very convenient way to make sure that you're complying, obviously, and a very quick way to get onboarded. But if you've already got perpetual licensing, then you probably want to bring those licenses onto the AWS platform. And you can do so through license mobility through software assurance. But I do encourage you to look into the detail of that. It's a very important topic. We do have a lot of guidance online, and you should absolutely talk to your Microsoft representative or your large account reseller to make sure you're getting that right. AWS is a very value-oriented culture. If you look historically at Amazon.com, right, it's very much about choice and lower prices. And that is also carried through into AWS. So we've got tools such as Trusted Advisor. I don't know if people would actually use Trusted Advisor. Maybe a couple of hands there. Then you absolutely should. That's something. A lot of you said you're already running an AWS infrastructure, so you should absolutely, go and have a look at Trusted Advisor this afternoon, because in the last couple of years, it's recommended about $350 million worth of savings to our customers. So you absolutely should go and have a look at that and see how you can optimize your infrastructure. It will discover things like underutilized machines. It will discover things like block storage volumes that aren't in use and stuff like that, and make recommendations on how to reduce your costs. So a very powerful tool. But in the last 6 years, AWS has actually reduced prices 47 times anyway. So just by sitting there, hopefully you're going to continue to get those price drops and actually see your bill going down over time without doing anything. And of course, no long-term commitments. A lot of customers, talk about growth. They always talk about the upcycle, right? It's a very positive thing. But you've got to remember, sometimes things don't work out as you thought. Projects get canned, right? And you want to be able to release those resources associated with those projects immediately, release that capital, and feed it back into programs that are succeeding, right? That's really important. It's extensive. So we're going to talk about, compute, block storage, and all the sort of core things that drive and support a Windows infrastructure. But actually, there's a lot of other services. So if you're a .NET developer, then one of the things you're going to want to do, you want queues, you want non-relational databases, you want relational databases, you want, things to deliver email for you reliably. You want all of these other platform services to actually augment the actual application you're building. So there's a lot of other services that you would want to pull in. There's also an AWS Marketplace. Where you can, with one-click deployment, you can actually search for, just like on Amazon.com, you're searching for software, you're one-click buying that software. It spawns virtual machines on your, that are configured for you by the vendor, it's best practice, and you're paying by the hour for that software. That includes Windows-based software as well. And if you go and find a lady called Jin, who'll be in the in the area out there with all the booths around the solutions architecture area, she's got some $100 credit cards for you to ask for running marketplace software. Worth dropping in there. There's a lot of people in the marketplace. Last year, 2014, we actually made 500 significant service improvements. So that's new services, but as well as significant improvements to services. So this is not a static picture. Right? The journey that you'll go on with AWS is constantly improving. In fact, later in the deck, I must remember, maybe you can call out to me if I forget, about OpsWorks. Actually, this morning, OpsWorks made an announcement that they're now supporting Windows 2012 R2. Right? So, again, it's a constant uplift. There's a new service called Simple Systems Manager. Last couple of days, this helps you do things like auto-domain joining. So if you've got auto-scaling, one of the things you want, right, is as machines get joined and launched, you want them to join the domain and be configured and managed by your Active Directory. So as you auto-scale Windows workloads, you want them to join the domain. So Simple Systems Manager is a process of doing that. And that's just been rolled out to a few more regions. So we're going to be continually improving that. So it's not a static picture. And for those of you in the audience who maybe have career ambitions, I'm sure you all do, or people who've got a management role, and your responsibility is to recruit people, train people, retain people, we have an extensive certification program for architects, developers, operators, and we have like different levels from the associate level to the professional level. So a very useful way of helping grow your business and grow your career as well. And it's very flexible. I'm kind of going to dodge off the slides here at this point and actually kind of talk about an experience I've just been having in the UK. One of my customers is the BBC, and they've just been through a really fantastic process of building a significant, shall we call it, a data management platform. It's got about 30-plus nodes in this cluster, spanning multiple availability zones, and in fact spans multiple regions. And they've been through a really good process of deploying the infrastructure and looking at different models. They've got forests, they've got different, it's a very complicated piece of software, and the way that you can configure it in so many different ways, they've been able to explore many of those different ways, automate the deployment, and then start to continuously monitor it so they can actually work out what is the best configuration of this complicated software so it can deliver the best value and best experience. They've been through that process. Now they've got this really high performance cluster spanning multiple regions, and they've got this chaos monkey running around that's actually just turning these data nodes off, and it re-replicates and rebuilds. It's fantastic. But it's the flexibility that they've been afforded by having on-demand access to infrastructure and being able to actually take real data to make really informed decisions about what is the right platform. And of course, change is constant. So yes, they've got it right now, but what's going to happen is that they know that other customers, internal customers, are going to onboard onto their platform and may well actually change the workload. The demands will change, but they can flex to that. They can change their infrastructure to match that. So it's important to know that you've got security. So you should feel confident with whether it's the independent certifications that give you confidence that you should be able to move to the cloud, whether you can use VPCs to be isolated in the cloud. That's a virtual private cloud. You're isolated. You create your own subnets. You're isolated. In fact, quite literally isolated, right? So if you were actually creating a VPC and you launched an instance, it would actually have no internet access. You couldn't access it. You couldn't RDP to it. Right? It would actually be almost entirely useless, except it could do work on its own. You have to make deliberate steps to actually make it access itself. So whilst people refer to the public cloud, it doesn't actually mean it's publicly accessible, right? So you get that straight. Obviously, I think the thing that people tell me the most is most important, apart from reliability and high performance, is familiarity. Is how quickly can we get started? How quickly can the people that have got skills in System Center, Active Directory, Windows Server configuration, maybe they've moved to desired state configuration, they've got PowerShell skills, how quickly can these people be productive in this environment? And the answer is immediately, straight away. So let's talk about laying down the foundations. You're confident that you should move to the cloud. You've answered all of those questions. And that absolutely Microsoft and AWS are great partners. It's a great platform running on AWS, very popular. You're not alone. So how do you get started? And there's many different ways you're going to get started. And you could start by logging into the web portal, our console, and you could just be using the web GUI, to click around. That's a great way to explore the service and get started. But very quickly, you're going to find that you actually want to automate things. You want to repeat things, right? So, of course, you probably start thinking about scripting. And, of course, we have a PowerShell. Hopefully, you can, at the back there, you can still make that out. But that's PowerShell to create a VPC. We have essentially a command line set of modules that give you access to pretty much all of our services. You'll find that the speed with which the AWS PowerShell tools reflect any new services and new capabilities in those services is very, very fast. So as soon as you see an announcement of a new capability, you should probably go and check and download the latest version of PowerShell. The PowerShell is built on top of the .NET SDK. But to be honest, when people are building and configuring infrastructure, I don't find them using .NET. I find developers using .NET to interact with data and do application-based things, but they don't necessarily use the .NET SDK to create VPCs, launch instances, although you could. And then, of course, you could just describe it. Yeah? So we have a very powerful tool set called CloudFormation, and that's what I've put at the bottom right-hand corner here. It's a declarative model. It's a document-based model of describing what you want. Yeah? So something like PowerShell is describing how to make that infrastructure. First of all, I want you to do this. I want you to, it's a very sort of model interactive way of actually creating that infrastructure. So CloudFormation is probably a little bit more like desired state configuration or a bit more like MSIs. You declare the how, you declare the what, not the how, to do the infrastructure, and allow CloudFormation to work that out for you. It's very cool because it's a document. You can put it in your configuration management system. You can do change configuration tracking between those. You can do diffs, so you can actually see what's the change between infrastructures. And when you give a new version of the document to CloudFormation, it works out what's the difference and how to apply the changes to your infrastructure. So it could be you've got a new version of the application. It works out how to deploy that across the fleet. So that's a very useful tool. A bit like the TV, you sort of pointed at the thing that's probably not actually listening to it. You've launched a virtual private cloud. That was just a few lines of PowerShell or CloudFormation, and you've launched an instance. So in the middle of this picture, I've got an instance, and on it, I've got a hard hat. That hard hat represents an IAM role, Identity and Access Management role. Why is it a hat? I guess it's like machines have different purposes. They have different hats. They wear different hats because they have different roles. It's a hard hat because it's security, right? What its primary purpose is to solve the problem of, I have a virtual machine running, and I want that virtual machine to interact with AWS services. Maybe, in this example, it wants to actually talk to CloudWatch. It wants to send metrics. We've got this EC2 config service I'll describe in a minute. It wants to send event log data. It wants to send perfmon metrics in real time. It wants to stream that data off so you can actually monitor your infrastructure. How does it do that? It needs to make secure calls to the CloudWatch service, but it needs access keys to do so. Those access keys are securely provisioned onto that host machine using what we call AWS roles, Identity Access Management roles. Okay? So you don't need to start embedding credentials into source code files or scripts, because as soon as you start doing that, they're in repositories, and keys have, surprisingly, if you look under a microscope, they've got legs. They run off. And you'll find them that they've gone to other environments where they shouldn't be, and next thing you know, someone might be doing some bit mining in your account. So be very careful, look after your keys, and one of our best practices is absolutely use Identity and Access Management roles to securely provision the credentials onto the machine. Our PowerShell SDKs, our .NET SDKs, all understand how to interact with IAM roles to get those keys, their temporary credentials, how to get those temporary credentials so that they can interact with those services. So in this case, we might have CloudFormation launching a Windows machine and telling that Windows machine, hey, run these scripts. I want you to install these modules, run this PowerShell script to come into service as a web server or come into service as something else. And in order to do so, you might actually want to use some PowerShell that actually interacts with our services, maybe updates a DynamoDB table or talk to CloudWatch. And it's going to, the SDKs, they'll be able to access those credentials without you actually having to provide them in plain text. So if you ever see plain text credentials in any one of your projects, you have to raise a big eyebrow and really drill into exactly why you've got plain text credentials anywhere. You really, at 99.9% of the time, you should never see that happening. EC2 config service is something that we've put onto the Windows machine images. It's optional. You don't have to. But by default, it's there. And it provides a set of enhancements, if you will. It sets the administrative password for you so that you can retrieve it and log in. It does things like automatically add block storage volumes that you've assigned to it, formats them and attaches them and makes them online. It does a whole bunch of useful things, essentially, to make Windows that much easier on the AWS platform. And includes things like the CloudWatch log agents, so that you can actually have event data, so event log data streamed off into CloudWatch logs. So if you have hundreds or thousands of machines, you want to be able to look across the entire fleet for average latencies or average queue lengths or something. You can start to look across the whole fleet and see your environment as a whole, not just as individual machines. And at the bottom right-hand corner there, I've actually got directory services. So actually, you can, as a service, get a directory service. So if you actually just want to run an isolated environment and you want directory services for your machines to be managed and domain joined, you can actually get Active Directory as a service, essentially. And if you go to the 4:30 session, I believe, I think in the other room, they're going to be talking about like SMB infrastructures, and they will talk also about desktop as a service, essentially, Windows workspaces. And in that, they'll actually talk about directory services and how that manages the workspaces. Also make a nod here to some of the modules that we've developed to give you seamless management across both your on-premises infrastructure and your cloud infrastructure. So System Center plugins, for example, so that you can actually manage virtual machines, whether they're on-prem or in the cloud, and just have that seamless experience across both. So you've created this virtual machine, but what comes next, right? So in this scenario, it's a very common scenario, and I'll talk to one of my customer examples, is that you've essentially got your data center, you're going to use Direct Connect, or you're going to use a VPN to securely connect your on-premises environment up into the AWS cloud environment. What's one of the first things you're going to want to do? In that environment, you're probably going to want Active Directory. So what you're going to do is you're going to either deploy Active Directory or use Amazon Web Services directory services. You're going to put it in multiple availability zones. Remember, availability zones are two physically isolated facilities made up of one or more data centers. But you would deploy Active Directory into both. You've got then questions to answer, such as, shall I extend the trust relationship from on-premise to the cloud, or shall I have Active Directory in an isolated fashion? Those are choices that you're going to make. Don't forget, you may actually end up with multiple virtual private clouds, each one with a different trust model. Okay? So it's not just that you end up creating just one VPC necessarily. What's the next step? Well, chances are you're going to have software such as SharePoint, Exchange, Link, Dynamics, Beanstalk, something. There's going to be other platforms that you want to deploy. And of course, they're going to sit inside that nice isolated private networking that you've deployed. It's going to sit there, and it's going to inherit and connect and integrate with the Active Directory you've already deployed and extended. So now you've actually got SharePoint. We've got white papers, very detailed white papers to help you through that experience. And it has a companion set of SharePoint, CloudFormation templates. So literally with a single click of a button, you can deploy an entire SharePoint infrastructure, best practice, spread across multiple availability zones, and we'll also explain in that white paper to make sure you understand the importance of how you bring your own licenses for SharePoint into that environment. So what might it look like? It might actually look a little bit like this. And in this example, we've got multiple availability zones. We'll always encourage you to use multiple availability zones. That's just a best practice model of giving you high availability of systems. But in this particular model, you've got a nice VPN connection. You've then got web front ends, which are using our Elastic load balancing service to load balance across the data centers and the web server front ends. And then you've got Windows Server failover clustering with SQL always on. And again, this entire environment, which is including the Active Directory and the replication between them, this is one topology of SharePoint, but this is just a CloudFormation template. So we're talking about the high-performance companies that don't spend time on time-consuming repetitive tasks. This customer can just punch out as many of these environments as they want. If they want a dev environment, click. They want a test environment, click. There's a developer who wants to rehearse a major upgrade. Give him access to an environment, because one of the things I've observed is that the biggest constraint going forward for most companies is talent. It's people. Yeah? We've removed completely the constraint of infrastructure and resources. Everyone has now got access to as much resource as they possibly need at the click of a button. That's gone away. You remove that constraint, what's the next constraint? The next constraint is talent, people. You look at any project plan, it's about people doing activities over a period of time, right? Last thing you want is those precious resources tied up waiting for infrastructure or doing repetitive error-prone things, right? If a developer needs a SharePoint environment, best practice, click a button, go, start practicing and looking at rehearsing your deployment of your next version of the software. That's what you should be thinking about, not, first of all, I must install Active Directory, click, 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 and putting CDs in, that kind of thing. Next up, Exchange Server. It's the same deal. White papers, detailing in excruciating detail, all the sort of networking, subnet designs, Active Directory integration, Microsoft best practices, including the preferred architecture that's I've documented up here, so you don't actually have to do traditional backups. And the way you do that is with sufficient replication and so forth. But this is all detailed, and it covers multiple scenarios from maybe sort of smaller 250 mailboxes up to 10,000 mailboxes. You could code bigger, but it's setting the scene for you. It's giving you the design principles. These are CloudFormation templates. They're just JSON documents. So you can look at them, you can change them, you can modify them to suit your own purposes. Important to note that you can bring your own licenses through the software assurance, but actually for your dev test environments, you should certainly explore your MSDN options and using dedicated instances. I mentioned that earlier. Right, one of my favorite database products, SQL Server. Multiple options here. The preferred option is to use our service called Relational Database Services, RDS, where you can get SQL Server essentially as a service, managed. So AWS will give you 2008 R2 or 2012, all pre-configured, Web Edition, Standard Edition, and so on. You get to choose whether you want high-performance SSDs or whether it's just for a small requirement, you just need a small amount of magnetic disk. You get to choose that. Do you want it multi-AZ, synchronously mirrored across data centers? You get to make those kind of choices. When do you want the maintenance window? When do you want backups to take place? You just define those, click, 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 or through a CloudFormation template, and it's deployed. Okay? You can choose whether you want a small machine with just a little bit of RAM, or you want a big machine with a lot of RAM. Kind of confusing for a lot of customers out there that we talk about gigabytes. Right, so 244 gigabytes of RAM is actually about 260 gigabytes of RAM. So I don't know if we're underselling ourselves or other people are overselling themselves, but either way, just be careful of the unit of measure there. You can choose whether you want encrypted databases. So you might just say, I want the disk volumes that this database is on to be encrypted. So that means that you can actually have standard or sort of web editions of the database product running, but as encrypted. That's disk volume encryption. What this allows you to do is, because you have a repeatable, predictable click button experience, you can upscale, downscale, it takes snapshots, backups, restore, all managed for you, you can start to challenge some old decisions. So one of the things I see quite often is what I call the mainframe database, where someone's tried to consolidate all of those SQL servers that were all around the company, tried to put them on one monstrous server. And all those consumers of that server now have a shared fate. When's it going to be patched? Well, your patching cycle doesn't match the time that I want it patched, but that doesn't really matter. Or the maintenance windows that you've got, or you're rebuilding your indexes, and when you rebuild your indexes, it really hurts me. You get a shared fate problem. And the reason people have done that, they've tried to consolidate these things for various reasons that may no longer be true, right? So you could actually say, this little dev guy just needs a 1 gig of RAM, basic little machine. He can go off by himself, do what he likes, make a mess of it, recreate it, doesn't matter. And you can have as many as you like, but it doesn't really have an impact on the scale of people you need to manage that number of servers. So do challenge some of those older decisions that were made beforehand. And it allows you to keep that ratio, that magic ratio of systems administrators to the amount of infrastructure really nice and low. Yeah. Last thing you want is a 1-to-1 ratio. Like for every database has 1 DBA and so on. You actually want to keep that ratio really, really high. And by using something like RDS, you can do that. But if RDS doesn't meet your needs, because there are some restrictions, one restriction might be you want to use unsafe CLR, for example. We don't allow that. But there may be you need actual host-based access. You've got some packaged solution that when you install it actually has to have host-based access. But in order for us to meet our SLA, we don't allow host-based access, because anyone could obviously go in there, upset the database, and we couldn't do the backups. So you could actually quite happily go and launch a Windows plus SQL Server AMI machine image. That will have multiple versions of Windows and SQL Server available to you, and you're going to get the licensing provided to you by us. And you could then obviously manage it as you see fit. Right, moving on then to custom application development, because obviously in a Windows environment, you're going to have this sort of standard Active Directory, Exchange server, SharePoint server, all these sort of standard platforms and products, but there's absolutely going to be custom application development. Some of those custom app devs will be extending SharePoint, but what I'm referring to here is custom app dev. This is the, the sort of probably the thing that's really the crux and most crucial part of your business. This is the stuff that you can't get off the shelf. This is the stuff that makes your business different from everyone else's, and that's why you're having to write custom applications, right? And this is where we get into that kind of really interesting software development. What do people want? Now, typically, we're moving to a world of, we have been moving for the last decade, to a world of agile development. That means teams that need to move quickly. Right? They need to take great ideas that people have, and they need to put those great ideas into service in front of customers as quickly as possible. Now, typically, there's been conflict, right? There's been, I as a developer, I'm heavily motivated to make changes as frequently and as quickly as I possibly can, because that's what's generating new features, new capabilities, and driving value in front of the customers. Excellent. My operators, they are measured by stability. So the last thing they want is change. Right? So this has been the big problem in any organization until more recently, and that's why people are talking about DevOps. You've got two fundamentally opposed types of organization. One wants change, one doesn't. So what you do is you create teams that have a shared goal, right? So the developers and the operations and the architects, the product managers, they're all in a team together. But for a team to be effective, they want to be quite small. Small teams have high bandwidth communication. Right, they can stand up at the start of a day, have their scrum stand up, they can be highly effective. And to be small, that means they can't be doing lots of extraneous tasks. They need to remove work that they don't need to do. And one of those tasks might be, we all know that a web application needs a load balancer, it should be stateless, it should be firewalled, it's a blueprint, everyone knows what they're. So no one should be spending time building and managing that. That's become very standardized. It should be standardized, automated. Those teams, when they're small, they appreciate what is core to the business at this point. You'll hear those teams talking about being product teams. They're not projects. Projects start, they finish, people move on. Products are about a team with a shared goal who are both thinking about the ideas, they're creating the ideas, they're delivering the ideas into production, they then own that product, they continue to improve on that product. It's not a project that people just come and go and have no sense of ownership for. As those teams get too big, they start to splinter off. They look at the different modules. What is the responsibility of those different modules? Is that a different product? If it is, let's move that off into a separate team. Amazon talks about two-pizza teams. That's a very popular term if you internet search that. I'm talking about Microsoft stuff here, so internet search, Bing or Google. Go off and look for two-pizza teams. It's talking about small teams that could be fed by two pizzas. As soon as teams get a little bit bigger than that, they start to suffer from communication problems and focus. So you'll start to see organizations structuring around DevOps and microservices. You're bound to have heard that term. And those teams also recognize that change is constant. Okay? And that's a very important thing to embrace. That's one of the sort of agile manifesto concepts. So if change is constant, then you want to be flexible. Yeah, you want to be flexible all the time. You don't know what's coming, so when that unknown comes to you, will you have the choices to be able to adapt? So cue Elastic Beanstalk. So this is an abstraction on our platform. It's not a different thing. It's an orchestration of best practices on the AWS platform. It allows people, those product teams, to focus on deploying and managing applications, not infrastructure. Good ideas, I write code, I test it, I deploy it. I'm not thinking about load balancers, protocols, ports. I'm not thinking about how that code gets deployed. I'm just thinking about, here's a good idea, I've implemented it, it's passed its test, and I'm doing continuous development and continuous deployment. I want to know that if that day comes when this abstraction that I'm using is no longer sufficient, because all abstractions have their limits, right? We've all had that experience. I remember what sticks in my mind is when I used to be a Visual Basic developer writing COM objects. And then at a certain point, the software became so complicated, the Visual Basic was no longer sufficient. It was a great abstraction, highly productive, right? And you could write great COM code in Visual Basic. But when you tried to write COM objects that needed to go a little bit further than iDispatch and IUnknown, you had to write C++. I didn't know how to write C++. So there's this huge chasm between where I was and where I needed to be, right? You don't want that in your platform. So you wanted to look after things like provisioning, load balancing, health monitoring, all the sort of standard things you'd expect from a web architecture. And ideally, you want it integrated into your environment. So something like Beanstalk, as I said, is an abstraction. It's an orchestration of all the standard components you're going to find. So it's going to be EC2, load balancers. It's going to be all the stuff that you would see anyway, but just abstracted. So if we look here, you'll see that it's essentially an EC2 machines, load balanced across multiple availability zones, some best practices such as the web servers have a security group, which is essentially a firewall, that will only accept inbound traffic from the load balancer. These web servers won't accept traffic from the web, right? So you'll see this documented as best practices elsewhere, but Beanstalk just embodies those in a standardized, automated, repeatable way that allows you to focus on development without having to think about the infrastructure. So I'm going to quickly switch over to a demo so you can get a sense of what that actually looks like in the flesh. And I will go over to my laptop here. Okay. So this is actually where you get to witness my extreme coding. It's really quite impressive. You'll be making me job offers later. So I've developed a very simple service. It's a very microservice, quite literally. Essentially, it has an API at the top. If you can read that at the back there, I'll do if I sort of zoom in. I've built a service. It's a RESTful API. I'm using the ASP.NET MVC Web API version 2, the very latest. Well, not quite the latest, but the latest production version. And if I pass in /API/person, it lists all the people in my database. So as you can see here, if I hit enter, this is a list of all the people in my database. So how did I build that? So inside my Visual Studio environment, I've got the Visual Studio plugin. The first thing that gives me is on the left-hand side here, I'll zoom in for you, is an AWS Explorer that gives me access to a lot, not all, but a lot of the core services you as a developer will use. As you'll notice, top left, it's saying which region do I want to interact with. Obviously, I'm here in Singapore. I want to deploy my code and application close to my user base here in Singapore. So I could obviously choose Dublin or Frankfurt when I'm back in the UK. Down the left, I can look at my EC2 instances, and in fact, that's what we're looking at just here. We're looking at one of my instances. So actually, as a developer, I don't necessarily need to leave my Visual Studio environment. Down here, I've actually got my code, so I'll show you what my code looks like. I have a person class as part of my model. And in my controller, I've cheated. I haven't actually created a database at all. I've actually embedded all of the data in the code as a static array. And I'm just using standard web API functions to map the URL to the query. So I've written this code. I've already deployed this code. But one of the things I've noticed is that I've made an error. My good friend Russell Nash, who's hopefully giving a presentation on big data somewhere else, I've missed him off. So for example, when we look through our code here, we can see that whilst I'm at the very top, very self-centered, all the other speakers are listed here except Russell. So I need to make a change to my code. So I can go in here. I can put a new line in. And put them in there. And compile the code. It's compiled, build succeeded, if you can squint at the bottom of the Visual Studio. So I'm just going to go there. I'm just going to do right-click, and I'm just going to click Republish this to my environment. I'm going to click that button. I'm going to say, yep, new version, click Deploy. So as a developer, I'm not really thinking anything about infrastructure. I've just thought about making my code change, and I'm just going to, 1 second, as I bring up the environment. It's giving me some sort of update here that's saying I'm deploying to the environment. So it's taking my code, I've compiled it, it's packaged it, it's moved it up into S3. It's now made that zip file, my code deployment, available to my instances. It's going to talk to those instances and say, you need to get the new version of the code and deploy that code. There are multiple different models I could choose at this point. I could actually say, I want you to roll the code out progressively. I don't want you just to deploy the code to every instance at the same time. I want you to roll that out progressively. I could choose a different model. I could say, well, actually, I'm going to have version 1 of my environment. I'm going to deploy version 1 here. And I'm actually going to create a complete replica of my environment over here and create another environment over here. I'll test my environment. And instead of promoting the code from this environment to my production environment, why don't I just make this environment my production environment? Yeah, it's already running. It's got the latest version of the code. I've just tested it. It's proven. In fact, maybe the activities of test have actually warmed up all of my caches. It's good to go, right? Why don't I just flip all the traffic to move to my new version of the website? So I've got different models for deployment. Okay, so I can do the rollout, or I can do the sort of big bang, or I can just do the switch over. So there's multiple different deployment options for me. How do we get on? So it's been deploying the new version. And Russell Nash, if you see, is now deployed at the bottom. So as a developer, I wrote code, I made changes, I skipped the test where I skipped the testing bit. That's just in the interest of speed, and I think you can appreciate that the change was fairly small. But now I'm deployed. And that was a zero kind of effort from me as a developer's perspective. Now, of course, Beanstalk applications don't need to necessarily run on the web. These applications could be just microservices sitting nested within our organization, right? And the new version of SOA, microservices, you could have lots of these little microservices deployed on Beanstalk environments around your organization, performing very specific functions owned and managed by product teams. So what does that look like? So you might have a development team, and that's their experience. They live inside Visual Studio. They do the coding. They do the deployment. Everything is good. But because it's actually just an abstraction of regular AWS components, then actually you could find that if I go into the regular, I've got federated access to the AWS console. I'm using ADFS. To get a single sign-on experience into the console. If I actually go into Beanstalk, I can actually begin to see my environment for what it is. I could get this actually from within Visual Studio, but I'm going to sort of take that further. I can look at the monitoring of the solution, that the average latency is 21 milliseconds. I could actually run a little test here. Just using a little bit of PowerShell, maybe to run a few thousand requests against the server. So I'll run that test, and we'll just see the monitoring of the system. But also, I could go to my services. I could go to EC2. So I actually might just be the operations. I may be someone who's not part of the product team, who's got responsibility for the infrastructure. And I can go to EC2, and I can see that there's a running instance. So this EC2 instance that Beanstalk is managing for me is just an EC2 instance. So we can actually apply all the standard security policies and stuff like that. So I might be a Visual Studio developer, and I've got the Visual Studio Explorer, but that doesn't necessarily mean I have rights and permissions to the rest of the environment. Okay? So that's just my EC2 instance there running there on a T2 medium. Maybe if we go back to monitoring, we'll start to see some of the impact of my little load test. So back to it. Yeah, the monitoring needs to be, isn't quite caught up. I'll come back and look at that in a minute. Where is it? Sorry. Yeah, so the test has completed. Yes, there we go, 12,500 requests now. The average latency is now 964 milliseconds. So it's a nice, fast little service, but only hits 0.4% CPU utilization. So I cheated a little bit there. Maybe if I'd scrolled down in the code, you would have actually seen that I actually put a little cache header in there so that it would actually cache the responses for 5 seconds. Because I actually use this as part of a bigger demo where I actually show the impact of maybe using CloudFront as a content delivery network on top of my web API. Because I know that my data doesn't change that frequently, I can just allow my content delivery network to cache the responses. And therefore, actually, the CPU load will be very, very small against my web servers. So I could actually run thousands and thousands of requests a second off a single little T2 medium that's costing me only a few dollars a month. Okay, so I will now switch back from the demo and wrap up. So as a developer, you can move from being thinking about all of the move away from infrastructure, and you can start to think about being inside your IDE, writing code, writing tests, focusing on the business problem, focusing on business value, and then deploying your application into multiple environments, choosing which deployment model suits your type of application, monitoring the solution, because as a DevOps team, you've got full responsibility, not just for the design of the application, but also the operations. You're the guy that's getting out of bed. You're the guy with the best understanding of the application, and you're the person that can make the changes. So it's a shared goal. But of course, it's not just about writing code in Visual Studio. There's a whole big, broad application lifecycle management picture. So if we zoom back out from Visual Studio, we've got some additional tools to help you. We've got Code Commit, which is a Git-compatible repo, so you can manage all your configuration and all your software. Maybe it's got your source code, your CS files, but maybe it has your CloudFormation templates. Maybe it has your Word documents. It can be anything you like. It can also hold very large binary objects as well, whatever you want. Then there's Code Pipeline, a service to orchestrate building and testing and deploying, right? So you're pulling that all together. We've talked about Beanstalk at the top there, and I mentioned OpsWorks earlier. So OpsWorks is another abstraction, an orchestration service built on Chef. And in the case of support for Windows Server 2012 R2, it is built on Chef 12. And it allows you to think of application stacks, multiple layers, and now with Windows support in OpsWorks, you can actually have IIS server layers. So I could actually be deploying that existing application into an OpsWorks layer, which may be part of a significantly more complex stack. So I talked earlier of when Beanstalk may no longer be the right level of abstraction for me. I need to get more complicated, deeper stacks, more complicated. Then I can maybe move to something like OpsWorks. So I've got a lot of choices. There should be no end of the road or a significant change in the services you're interacting with. Because don't forget, OpsWorks, Beanstalk, they're abstractions, and they're just working over the standard AWS components like EC2, load balancers, and so forth. So in summary, you should be able to run a fully fledged Windows environment, bringing your own licenses or consuming them from us. And that could be everything from Active Directory and classic platforms like SharePoint to custom application development and .NET. There should be really no limit. You can integrate it with on-premise if you want over Direct Connect or over VPNs and extend your Active Directory, or you don't have to at all. You could just be running Beanstalk in the cloud, running a web application. It really doesn't matter. You get to choose. You can have both. Then all of the tooling that we provide for .NET, SDK, PowerShell, command line modules to give you that very familiar way of interacting with AWS resources. Of course, fully supported by us. So when you log calls and they're Windows-based and IIS-based, our support teams are fully able to support you. So I really encourage you to go to our landing page, awsamazon.com/windows. There are loads of others, actually. I could have, but it would have got rather small at the back there. There's /Windows, there's /Visual Studio, there's /PowerShell, there's quite a few things. But if you start with Windows, you'll find links off to all of the other services that we have to offer. You'll get more descriptions about how to license, for example, what platforms are supported by the license mobility through software assurance, what's eligible, what's not. And of course, please go to the white paper. It's a really fabulous resource to find things like SharePoint and Exchange, so you can get that one-click deployment for some fairly hefty and clever and complicated environments. So with that, thank you very much indeed.